We're going to continue drawing some more Lewis structures. Remember that these are our steps. Find the valence electrons, organize the atoms with some symmetry, and then draw the dots and connect them like we did with the red ink here. So I'm going to leave a few of these for you to practice on your own. I'm going to jump down here to the CH2O, which is formaldehyde, the chemical that they use to store specimens in a biolab. So as I look at CH2O, this is an organic molecule, so it's got a carbon in the center of it. When I go to write this, when I arrange the atoms, with organic molecules, you're going to default to putting carbon in the center of your molecules. So that means if I put carbon in the center, with symmetry, I see I have two hydrogens. So let's put a hydrogen on either side of it, and then an oxygen maybe above here. And you'll get better at the layout of the atoms the more of these that you do, because there's a limited number of molecules we'll really see. So once I've got that organization, now I want to draw the Lewis dots. Those are those valence electrons on each atom, and then we'll connect them. So hydrogen, remember we go to the periodic table to figure these out. So hydrogen, group 1, has that one valence electron. Carbon is in group 4, so it has 4 unpaired valence electrons. Oxygen is in group 6, so it gets 1, 2, 3, 4, 5, 6 valence electrons. All right, be very neat here, otherwise this just starts to look messy and it's hard to tell where your electrons are. And these are basically all or nothing kind of questions, so there's no partial credit. You either have the right structure or you don't. So now I want to connect the dots, connect the unpaired electrons until I get full outer shells, which is usually an octet. So I'm going to connect unpaired to unpaired, unpaired to unpaired here. And then I want to check my structure, and I should notice that there's 2 unpaired electrons here still. These are adjacent atoms, carbon and oxygen. So even though it's messy right now, they can share electrons. I talk about these atoms being neighbors. I go to my neighbors for birthday candles, for eggs, for mint extract, whatever I forget on a given day, your neighbor can help you out. It's right next to you. Same with the atoms as they form bonds. My sister lives up in Montana, so I can't go reach and share an electron way up here. I have to only share with that next door neighbor, and that's true with my molecules. Now, this looks a bit messy, so like we redrew up here, we can also redraw this. So carbon in the middle, single bonded out to hydrogen, and then C to O. I have 2 bonds, and then you always want to make sure and copy over those, what we call lone pairs of electrons. And I could scoot one over here to the side or scoot a pair over here instead if I wanted to. So this is my Lewis structure. And we will, in the next set of slides, be building them and looking at some of the shapes here. Next up, let's try carbon dioxide here, so CO2. So again, I'm going to lay it out symmetrically. So this would be symmetry. This would be like me taking each twin for a walk, so I grab their hands. This would be not symmetrical if I went COO, so we don't want to do that. We want to have this symmetry going on, okay? So once I've got the symmetry, now I'm going to put those 4 electrons on carbon, 6 on oxygen. These are the valence electrons. You'll have these memorized pretty soon. And I want to start by connecting with single bonds. All right, so I've got single bonds connecting. I can see there's still unpaired electrons. I can't put them together on the carbon. I have to reach out and share with a neighbor. So I reach out here and share. Now a common mistake is you'll say, hey, I'll take this electron and also share it here. If I have 1 egg, I can't loan it to this neighbor and to that neighbor. My 1 electron has to pick a side, okay? And so I do fortunately notice there's an unpaired electron here and here. So again, it looks messy, but this carbon can share with a neighbor, right? And if I redraw this, clean it up, I've got double bond, and then I'm going to scoot those electrons around just to make it more symmetrical. This would be a good way to draw that Lewis structure. All right, I'm going to leave these 2 for you, and we'll do one more on this page. This molecule is going to be a little bit different because, as you can see, it has this 2 negative, and that tells me that I've added 2 extra negative electrons. So symmetry-wise, let's put carbon surrounded by 3 oxygens. All right, so reaching out to all 3. Let's add our valence electrons, 4 for carbon, 6 for oxygen, 6 for oxygen, 6 for oxygen. And then this is where these 2 come in. I have 2 extra electrons, and if I look at electronegativities, oxygen has a higher electronegativity than carbon, so that means it wants electrons more. So on 2 of my oxygens, it doesn't matter which ones, but I'm just going to default to this one. I'm going to plug an extra electron in, and on this one, I'm going to plug an extra electron in. Those 2 are these 2 electrons that I gained. Okay, you don't have to make them X's, but I just made them an X so you could see that they were new and added on. Now I'm going to do my usual. Connect, connect, connect. And then I notice that there's unpaired and unpaired here, so I'm going to pair those up. I could clean that up and straighten it out like this. And then the last thing I have to do with an ion is I have to explain why there's extra electrons there. So I'm going to put this in big brackets, and I'm going to put that 2 negative outside. This is the carbonate ion that we saw a couple slides ago when we were naming, and that's how you handle negatives. If you had a 1 negative, you would add 1 extra electron. If you had 3, you'd add 3, and those extra electrons always go on the outer atoms. So there's some left here for you to try, and now after that we're going to move on to some shapes.